Okay, we're going to talk about your study guide. This is going to cover just the first 10 problems. So the first page, which is what the first day of the test would look like. So problems 1 through 10, and I'll make a second one for the other half. Looking at this circle, what I see is central angles. So we need to remember that a central angle is equal to its arc measure. So if they're wanting us to find the measure of this arc, D around to A, ending at C, I need to find the angle measures of these. And those will be equal because it's a central angle. In other words, the angles all come from the center of the circle. So I'm going to notice that this is 180 degrees right here. DB is a diameter, so that's a straight 180. And then for this problem, all I would need to do is add up 180. Let me get that the right size, or at least smaller. I would have to add 180 for this part, and then another 35 for this part, and add that up, and I will have my arc measure. So let me get this cleaned up. And 215 degrees would be DAC. If you needed to find, let's just do some other examples. If you needed to find just this part, well, I would get what I just found, 215, and subtract it from 360, and that would give me just this angle. I could find the missing angle here by taking 180 and subtracting these 2 degrees from it. So there's lots of different things you could do with central angles. All right, number 2, we are looking at this chord. It says the chord is 16 inches for AB. Remember, a chord is a line segment that goes through a circle and hits it at 2 places. So a chord AB is 16. Chord BC is 5. And they gave us a right angle here. So this angle right here is intercepting this arc AC, and we also know that it's intercepting this diameter. So either way you look at it, you would know that this angle, because it is an inscribed angle, inscribed angles are 1/2 the arc that they intercept. So if this is a 180 degree arc, then this is a 90 degree angle measure. So 90 degrees here. That gives us a right triangle. So I can use my Pythagorean theorem. That pops up all the time. 5 squared plus 16 squared equals x squared. How do I know what to put by itself on the equal sign? That is your hypotenuse, and that is always directly across from your diameter. So working these numbers, I'm going to have 25 plus 256 equals x squared. Solving that, I have x squared equals 281. Square root of that, square root of both sides gives me x equals 16.76. And then what it's asking for, though, is the radius. So we know a radius is just from the center out. So this guy is the radius. So that's just going to be 1/2 of my diameter. So the radius is 1/2 of that, 8.38. My diameter, it also wanted, is 16.76. Okay, so the key thing here, an inscribed angle is on the circle, and we want to often look at the arc that it is intercepting to do our problems a lot of times with these. All right, number 3. We're using the same circle, find their circumference. So we just need to, let's get these numbers back. Circumference is 2 ways to do it. 2 pi r, or the diameter times pi. I've got the diameter, so I'm just going to say 16.76 pi. And this does not say how to leave it, so if I go ahead and leave it as a decimal, just multiply that times pi button on your calculator. Oops, I think I went off the screen. So I've got more screen than what you're seeing. 16.76 pi equals 52.65. Okay. So circumference. Find the length of the arc. So pay attention to if they're looking for angles or arcs. So we're looking at arc. And this length, a lot of people miss this on your quiz. We're going to leave our answer in terms of pi. All right. So the length, different than an arc measure. A length is an actual something you could measure. Whereas a degree measure is, I mean, it can be measured, but it's not going to change no matter what size your circle is. So length is your circumference times the arc measure and divide it all by 360. So we need two things. We need the circumference. Circumference is, we have a radius, twice the radius times pi. So that's 48 pi. For now, I'm just going to leave it as 48 pi. So my length is 48 pi times the arc measure. So we're going from x around p to y. Well, if this is 90, because it has a right angle indicator there, so if all of it is 360, so we've got 360 minus 90, and that equals 270. Okay, so 48 pi times 270, 270 out of 360. And when you multiply all that out, leaving it in terms of pi, so I'm not going to enter pi in my calculator, I will end up with 36 pi for this one. Okay, so arc length, not arc measure, but arc length, and that's what you need to pay attention to. We need to find, multiply the part of the circle that I want times the circumference. All right, number 5. MO and PI are radiuses, so part of my shape looks to be cut off here. This is N. All right. So it's telling us those are radii. MN and PN are chords. If MNP is 74, what is the measure of the central angle POM? So this is what we're trying to find out. So this problem deals with inscribed angles and central angles. So we need to remember that if we have an inscribed angle, that means it's on the circle, and it is going to equal 1/2 the arc measure of its intercepted arc. Central angle will equal the arc measure. So how am I going to work this? I know I'm going to look at what does this measure that I know, start with what I know. It intercepts the arc PM. So it is going to be twice, this arc is going to be twice that arc angle measure. So we're looking at 148 for that arc measure. And since central angles equal, that means this central angle equals its intercepted arc. So our answer is 148 degrees. Okay. Number 6. All right. The piece of knowledge here that you need is that we have an inscribed quadrilateral, and the angles opposite each other are going to be supplementary. So let's see what they tell us. ABC is 85. And I just put congruency marks there. They're not congruent, they're supplementary. 85 degrees for ABC. And measure of arc AD is 82. And we need to find just DC. So we're looking for this guy. All right, so on these kind of problems, check for, with what you know, I'm going to be looking for the idea of intercepted arcs and see if that can help us. So I'm going to pay attention to, let's go with a different color here, the arc that this angle intercepts is ADC. Right? Do you see that? All right. So if that intercepts ADC and it is an inscribed angle, so it is 1/2 the measure of its arc. Well, we don't know the arc, so the angle, we need to double it. 85 times 2 would give us the arc measure. So 170 degrees is the arc measure here. All right, and they gave us that just AD was 82. So we know the whole thing is 170. The arc AD is 82. We're going to take that away. And we're going to end up with the measure that we need, 88 degrees. So CD is what we're looking for. Equals 88 degrees. Okay. So a couple things to know here. Your opposite angles are supplementary. As it turned out, we didn't really need that information here, but you may need that. So these should add up to 180, and I mean they will. They're supplementary. Okay, number 7. AC is a diameter, and CAB is 55. Let me switch colors. That may not be showing up very good. Let's go, we'll go orange. CAB is 55. Okay. And what do we need to find? The measure of AB. AB. Okay, well, what do we notice here? The arc AB, it has an angle, it is the angle that inscribes it, I guess I want to say, is this angle right here. So if we found out angle BCA, we would know arc AB, and that's what we're looking for. Well, how can we find that out? What else do we know? Well, we know that AC is a diameter. It told us that because we need to know then that this angle is intercepting a diameter. So look at it, either it's intercepting a diameter or an arc that is 180 degrees. So it is half that, it is 90. And now we have two measures of a triangle, so we can calculate the third. So 55 and this need to equal 90. So 45 degrees there. And then across from then double that, and you will get the arc AB. Oh, except I've added wrong. Sorry, I knew something was not looking right. Okay, so let's go with 35. 35 and 55 equaling 90. All right, so then across from that is going to be double 70 degrees. All right, now let's talk about, there's another way you could have worked this problem, just in case you want to see a different way to do it. Let's go in blue. You could have also worked this by, they gave us 55, and its inscribed, its intercepted arc is 110, right? Because that's double. And if we know that this, let me switch again. So from C around to B around to A, we know would be 180 because this was defined, CA was defined to be a diameter. Okay, so you know that has to be 180. And so if this is 110 from C to B, then the difference of 180 and 110 would have to be AB. So you could have done 110 minus 70, no, 180 minus 110 would give you 70. And that would be also another way to look at it. So there's multiple ways you can get to the answer sometimes. Okay. Is CB tangent to circle O? Well, if it is tangent, then we know that it's hitting in one place, and the radius that it shares a point with is perpendicular to it. Well, that creates a perpendicular, a right triangle, and therefore, if it is a right triangle, then Pythagorean theorem must be true. So that's what we're going to do, is see if Pythagorean theorem is true. So what we have here is another radius up here is 4. The hypotenuse is 8 plus 2 is 10, and we're given 6 there. So we're looking at, is 6 squared plus 8 squared equal to 10 squared? Well, let's try it out. 36 plus 64 equal 100. And 100 does equal 100. So we can say yes, it is a tangent. Okay. All right, last one for this video, number 10. Find the value of y and measure of angle C. All right, well, we have to find y before we can find the measure of angle C. Now, how do we know what to do here? What I'm going to notice is this angle is inscribed, it's on the circle, and I'm going to look for its intercepted arc, which is AD. And then the other angle that's noted here, I'm going to look at its intercepted arc, and it also intercepts the same arc, AD. So two angles that intercept the same arc must be equal because they are both 1/2 the measure of the intercepted arc. So if they are equal, typically, when a problem sets things congruent, we can then say that they are equal. So y plus 10 equals 6y minus 15. Minus y, solve for y. Get all your y's to one side. Get your numbers to the other. And we'll end up with 5y equals 25. Divide by 5. Y equals 5. Alright, so that, don't stop there. That's just y. You needed to find y, but now you need to find the measure of angle C. So we're going to take 5, substitute it into the angle C. 6 times 5 is 30 minus 15. So it's going to equal 15. So the measure of angle C is 15. And we know they're congruent, so this should also equal 15. And it does. So that's good. And then the measure of AD we would also know, because these are inscribed angles, they are 1/2 the measure of the arc that they intercept. So 30 would be twice 15. So lots of things you could work on with this one. All right, so that ends that, and you can catch the other video if you want part 2. Have a great night. See ya.